welcome to Module 2, Lesson 9. So today's lesson is going to be a little bit different. We're going to be doing some hands-on-ish activities, just kind of give you a visualization of some of these things. So we're still talking about measurements here. We've talked about time, we've talked about weight with grams and kilograms. Now we're going to shift gears again, and we're going to be talking about liters. Now, once again, don't be like, oh, we're changing topics already. Grams and liters and kilograms and milliliters actually have a very, very similar unit of measurement. This is why we're using the, we're not using the imperial, we're using the metric system right now, because the metric system, they are kind of the same in all realms. So, time is how long something has lasted. Grams and kilograms is how heavy something is, how much weight it has in it. Liters is more along the lines of volume. It's being able to fill up something and say, this is how much liquid is in something. So right here is 1 liter. If you can see right here, it says 1L dash or slash 1,000 ml. So let's talk about what those means real quick before we move on. So the L stands for liter. So if you see a big L like this, like 1L, that says 1 liter. If it says ml, like this right here, little m, big L, that is important because when you get later math, if you have a big M, it means something different. So keep in mind, little m, big L is milliliters. And just like how 1 kilogram is equal to 1,000 grams, 1 liter is equal to 1,000 milliliters. Now this is a very nice measurement because it's by 1,000. You don't have to remember them separately. He's like, oh, metric, they're both by 1,000. So just kind of keep that in mind. Now, let's go ahead, kind of give a little brief introduction there. Let's go ahead and talk about what we're talking about. So we're talking about, I can decompose a liter to reason about 1 liter, 100 milliliters, 10 milliliters, and 1 milliliter. So basically, we're still doing what we're doing with like grams and kilograms, but now we're just using another unit, liters and milliliters, volume of liquid. So just as a reminder, I could put 1 kilogram right here and split that off into smaller things. I could say I have 750 grams here. And wait, how many grams does it make to take a kilogram again? Right here. 1,000 grams equals 1 kilogram. So if I have 750 grams, how many grams do I need to get to 1 kilogram? Wait, what does 1 kilogram mean? Could I also maybe write 1,000 grams in there as well to show that they are the same thing? Yes, and if you need to do that, do that. Do what you need to do to help remember what 1 kilogram is. So if I'm at 750, how many more do I need to get to 1,000 or 1 kilogram? You would write 250 there, because 750 plus 250 grams put together equal 1,000 grams, which then converts to 1 kilogram. It's kind of like seconds to minutes and then minutes to hours. Just kind of keep that in mind. We're still converting a similar way there. So 1 kilogram is 1,000 grams. And I could do this with liters as well. So I'm going to kind of focus primarily on the liters one right now, because that's what we're primarily talking about in this lesson is liters. Remember, this still applies to kilograms and grams as well. So if I had 1 liter here, if I had 900 milliliters right there, how many milliliters would I need to get to 1 liter? Now once again, bigger number, but the unit is smaller. It's a smaller amount. So I could also write that you need 1,000 milliliters to equal 1 liter. So if I have 900, I need to get to 1,000. How many more do I need? 100. And now be specific here. 100 what? 100 milliliters. Now this is why I'm kind of pushing for you to make sure you put down what are we dealing with. Are we talking about like Skittles or apples? Like 2 plus 2 what? Equals what? 4. Well, 4 what? For chickens, for apples, for Skittles, for scholars. You get the idea. What is it? Right now we're in milliliters because now that we're dealing with a metric system, if I just put 900 and 100 there and 1 here, well, what are we in? Are we in liters? Are we in kilograms? Are we in like you get the idea. Meters. It's important to know what are we in so we know what we're measuring. So keep that in mind. Now, we're going to take a step back from this for a second and show the visualization of how these things work. So as I showed before, I have 1,000 milliliters or 1 liter because they're interchangeable here. And it comes up to that line. If it was higher, it would be more than 1 liter. If it was lower, it would be less than 1 liter. Now keep in mind with what we're going to be doing here, I will be pouring these in other containers as well. For the purpose of this, we're going to say that all the liquid in here, when I pour it, makes it in there. There'll be a couple of droplets left off, but for the purposes of this being friction and things not being able to move, just keep that in mind. So, just kind of as a start off, a basic one, if I have this little tiny cup here that only goes up to 250 milliliters, make sure you can see that right there, and this big one right here that is 1,000 milliliters, hopefully you can be able to tell something here. Which one's bigger? I'm hoping you're saying this one. This one is the bigger one. You can visually see that. This one in my hand right here is much larger than this tiny one here. So the question is, I have 1 liter here, or 1,000 milliliters, and this one can hold up to 250 milliliters. Can I take this one and pour it into here? Can I empty this entire thing into this? Well, hopefully you're saying no, because this is not fitting in here. And we can actually go ahead and try that. So I'm going to go ahead, do my very best not to spill on all my stuff here. I'm going to pour this one into this smaller one. Now, I'm also going to ask you guys to take a little bit of an extension here. If this can only hold up to 250, and I pour out of this one right here, the 100 milliliters, and I pour 250 of this into here, think how much will be left in here. Think about that for a second while I do this. I'm going to do this carefully as I can. So go ahead and pour it in. Make sure you guys can kind of see it to an extent so you don't think I'm doing anything tricky here. Make sure I get right up to that line. Let me turn a little bit so I can see. And there we go. Now I have filled up to that line. It's just a tad below, but for the purposes of what we're doing here, we filled it up exactly to that line. Now, visually, have I emptied this entire thing? No, not even close. So if I pour this back into here, how much would then be in here? So this is a basic subtraction problem. I had 100 or 1,000 milliliters here, and I took away 250. The question is, how many are left in here? Now, that might seem like a little difficult question here, but let me ask this question. If I had 10 pencils and I took away 3, how many pencils would I have left? You start with 10, take away 3. 1, 2, 3. Oh, wow, what am I doing? 10, 1, 2, 3. There we go. I'm like, the fingers I'm holding up are not showing what they should be. 7. So same thing. If I have 1,000 and I take away 250, what is that? And we can go ahead and quickly do that right here. Let's go 1,000 minus 250. 0. You can't take 5 from 0, so I got to come over here, borrow, make that 10, make that 9, borrow again. So that is 750. And if you're like unsure about that, maybe going to thousands is a little difficult. Try to imagine this. 100 minus 25 is 75. You're just adding a 0 on each one of your units here, and you basically do the same thing, and the answer just has that extra 0 on it. Just kind of keep that in mind. So keep this in mind. Also, this is considered the capacity. Technically, we can fill it up more. We're ignoring that right now. We're saying this line is its capacity. So right here, I have maxed out its capacity. Now, if I pour this back into this larger one, will this larger one overflow? It might, maybe. I don't know. It could. Or maybe we can follow the laws of science and math to determine something. If I have taken a certain amount out, If I put that same amount back in, it should be the same, basically, right? So we should be able to assume that if I put 250 milliliters back into 750 milliliters, it should equal back up to 1,000 milliliters or 1 liter. Let's go ahead and try that. So just to prove a point here, I'm not going to be careful here. I'm just going to dump it in. And if it's too much, it's going to overflow, right? Which means it will just mess up my computer, it'll mess up my keyboard, my computer monitors, my phone, a whole bunch of other things here will get ruined if I'm wrong here. But I'm trusting science here. I know that since I took this out of here, and I haven't added anything else to it, it should be able to fit quite nicely. So I'm just going to go real fast here. Yeah. And look at that. It ended at the exact spot that it originally was at. Now, for this one, we can make it pretty obvious. This entire large thing is not going to fit in here. All of this water ain't going to fit in here. But what about this one? Will it fit all in here? And now, you should be able to see comparison-wise, the answer is still pretty much no. But I do want to point something out here. The size of these bottles are a little bit different, right? They are not the same height, but this is a little shorter than this one right here. But this one's a lot skinnier. Keep that in mind. Now, the capacity, how much can be filled in here on this one, says 500 milliliters, or 0.5 liters, or half a liter. So 500 is half a liter, so 500 milliliters. On this very large one, 500 milliliters is down here. And if you notice, 500 milliliters is a lot higher on this one. So these numbers must be wrong, right? If this holds 500 milliliters, 500 milliliters on this one should be at the same height as this one, right? Because it's just that height. So maybe we're wrong. So I'm going to pour this out halfway, and I know it's halfway because it's half of 1,000, 500. And I'm going to see if it actually matches up to 500 milliliters here. So I'm going to hold it up, just make sure you guys can see it. So I'm going to have the numbers towards me just for a second, just so I can see. So I'm not looking at the big one right now. I'm filling up the tiny one. I'm going to fill it up to 500 milliliters. And if the numbers are correct, the big one should only be filled up to 500 meters again, since I've taken away half of it. And there we go. So right now, we can look at it. Oh, where did it end? And, well, let's double check this one too. Let me turn it so you can see it. This one right here, look where it did end too. Wait, now I have a question here. They both are marking 500 milliliters. Why is this 500 milliliters higher than this 500 milliliters? Why would that be the case? They're the same amount. I don't understand. If they're the same amount, they should be the same, well, height, correct? Well, there's a couple things you need to keep in mind here. The biggest thing you need to keep in mind is that they're not the exact same shape. Now, this container is wide. It's this wide, right? Now, this other one right here is skinnier, which means if it wants to have more in it, it needs to be taller. It's kind of an idea. If you have a cup, and the cup is this big, it's super duper wide, you can fit a lot in there without having to go very high, right? Now imagine the opposite. Imagine you have a very, very tall glass. It's only that big, only that's tall. If you want to get anything in there, you've got to make that a very tall glass in order to get any real substantial amount of liquid in you, right? So just kind of keep that in mind. The shape and size of your container will drastically change how things appear to be. Because I can promise you, I could make 250 milliliters taller than 1,000 milliliters in this container just by making this very, very, very skinny, making it into like a syringe or something. Just something that's like that tall and that skinny. And it would fill up very, very fast because it doesn't have a whole lot of space to go in and spread out. It goes in, spread out just a little bit, and then it has to go up. There's no other way for it to go. So just kind of keep that in mind. Now, just as another example here, if I were to completely empty this one out, completely empty out all 1,000, I've done it halfway, but let's say I take this and I get rid of it. How many of these fill to its capacity, 250 milliliters, would it take to completely fill up something that is 1,000 milliliters? Now, once again, we could actually do this, but the sink's way over there. I don't want to get up and keep going over. So we can also do a little thing called math to solve this problem. And this is called groups and in each group. See, we're coming back to what we were doing at the very beginning of the year. So let me grab this erase here. If I have a group that is 250 milliliters, and I'm trying to get to 1,000, let me go ahead and erase this a little bit right here, milliliters. And what does 1,000 milliliters mean again? What's another term we could use for that? Liter. So I'm going to say 1 liter here, just in case we forgot. How many groups do I need in order to get that? Well, you could skip count by 250 a certain amount of times until you get that. You could, which might seem like a whole lot. You're like, I might not be able to skip count by 8s, let alone 250. So let's do another perspective on this. 250 and 1,000. What's 25 plus 25? 50, right? So 250 plus 250 is 500. 250 plus 250 plus 250, so 250 times 3 would be 750, because 25 times 3 is 75. And if this doesn't make sense to you, you can just straight up go 25 or 250 plus 250 plus 250 until you find the correct answer. If you need to do that, that's fine. Try to do the multiplication way, but if this is the method that works for you right now, just do this right now. And you could find out that it would take 4 milliliter or 4 bottles of 250 milliliters to fill up 1,000 milliliters. And in a way, I am going to do this. I will show this to an extent. So as of right now, the amount of water in both of these combined, 500 milliliters together, this equals 1,000 milliliters, correct? Once again, I can prove that just by blindly pouring this in here and believing that's going to work. So I'm just going to go. I'm not going to take my time. I'm not going to wait. Oh, it's climbing really high, and I'm good. All right? Don't need to worry about that. So what I'm going to do here is I'm going to fill up this 2 liter or 2,000 milliliters container with this, which means if this is 1 liter and this is 2 liters, that means I can tell you it's only going to fill this up halfway. So let's go ahead and do that real quick. Oop. I missed it a little bit. I'll clean that up later. I'll go a little slower to make sure I'm not making a mess now. I don't want to lose any of the water, because if I lose too much, it might skew our results. There you go. Now, a little bit did go out, but for the most part, we can agree that says 1,000 milliliters or 1 liter. Now, I'm going to use this to fill 250 a certain amount of times to fill this up. So we're going to do this real quick because I know this is getting into a little bit of a longer episode. But let's go ahead and do this. Go ahead and count how many times it fills up to 250. So we're going to do that real quick. So 1. Oop, went a little too high, but we'll work with it. So 1, put that in here. Try it again. 2 is filling up. Oop, just need a little bit more. 2. Well, move it over here. I'm going to try to speed this up a little bit without making a mess again, because the last thing I want to do is go home all wet. And then, so that we're at 2 right now. 2 of these. This is number 3. A little too high right there, but we'll deal with it. 3. Last but not least, 4. I am believing that, based off of what I know about how math works, if I've taken 3 parts out of here, the last part should fill this up perfectly. So I'm going to make sure I don't spill myself, but I'm just going to let it go until it's empty. Oh, it's getting close. All right. Now, bear in mind, I did fill 2 of the other ones a little too high, so I was expecting this to be a little lower because, well, I overfilled the other ones, which means I gave them a little bit more than I should have. So I'm going to put that here, and it should bring it right up to 1 liter, or 1,000 milliliters. And there you go. So that's a really nice thing about math, is that if you start out with an amount, that amount will always be that amount unless something happens to it. The only way that I could split this out into 10 different groups, and it'll be 100 in each group. But when I put them all back together, it's still going to be 1,000 milliliters or 1 liter. The only way that it wouldn't is if I got one of those and I drank it, then that water's gone. Then that total number would change. But keep in mind, that total would still be the same amount. Now, that being said, this is probably a very long episode for you guys. Apologize for that. But I thought it was still a fun thing to do. So with that being said, hopefully this was helpful. Hopefully this was also helpful. And I hope you guys have a great day. See ya.